the dam cannot full to its capacity. And whenever the news flash in the newspaper that the dam remains 23% of water, our student doesn't know exactly what is meant by 23% of water. And for that, we can perform an activity to make him learn exactly what is the full capacity of dam and how the water reduces. They have a question that 23% water means exactly what? For that purpose, we can carry a practical to explain it. Here is a plastic pot with 0 to 100 digits on it, and a tap is fixed at the bottom of the pot. Pot holds 100 units of water. It means this pot is full to its capacity like a dam. Now we can give them an experience how the percentage of water decreases gradually by opening the tap. By taking out 40 units water slowly, we can ask a question. Now let us watch. We are reducing 40% water from the dam or from the pot now. Now after reducing 40 units water slowly, we can ask a question that how many units of water remains now? In this way, we can explain 60 unit of water out of 100 unit means 60% water now remains in the dam.
Very nice, sir. Similar experience can be given to the students by using the mobile battery recharge. That how much of the recharge is left out of battery. That is also given in the percentage.
Exactly. We can give an additional experience. As shown in the next slide, we can see there are 100 biscuits in a box, out of which 20 biscuits are circular in shape, 50 biscuits are rectangular in shape, however 30 biscuits are triangular in shape. Now by showing this type of images or actual biscuits, we can ask the student about what percentage the circular biscuit are in the box, so that they can understand in the box out of 100 biscuit there are 20 circular biscuits. That's why they can give us an answer 20%. Rectangular biscuits are 50 in number out of 100 biscuits. That's why they can tell us rectangular biscuits are 50%. A half we can say 1/2. Triangular biscuits are 13 number. Thus 30 out of 100 biscuit can be written as 30% biscuits. Such experiences clears the concept of percentage by carrying out discussing among them.
That's really nice, sir. We can give them many more experiences of percentage. Now, if you can take us to the next slide, we can see that there are many shops on which there will be a board calling naming it as a sale. There will be sale of a 10% off, 20% off, 50% off, or 75% off. Like this, many more experience could be developed.
And you can show them a bottle of medicine on which different percentage of components are noted on the bottle. However, in this unit various examples are solved. We can use percentage for comparative study between two matters. Let us watch the next slide. Here we can see an example is there. For summative evaluation in certain school, 720 students out of 1200 students awarded A grade in mathematics. What is the percentage of students getting A grade? In this example, there is 720 students who awarded A grade out of 1200 students. Here, the total number of students is not 100, it is over than 100. So, we have to solve it as percentage. Therefore, suppose the student getting A grade are A%. Let us write it in two forms. The ratio of the number of students getting A grade to the total number of students. Obtain an equation and solve it. We get equation as shown in the slide. A upon 100 equal to 720 upon 1200. You can see we multiply by 100 to both sides of this equation as we learn in the previous unit equation, and we get by solving this 60% as an answer. You can notice there is no use of formula. The dependence on formula terminated by this method, and a new method is given which is applicable in other units like ratio and proportion, simple interest, and percentage profit, percentage loss too, as well as in the next standard too. Here I stop. Thank you.
Thank you.
Hello everyone. In this session, we are going to learn various tests of divisibility. Mr. Sujit Shinde, member of study group mathematics, is here with us. Sir, in previous class, students have already learned about the divisibility of 2, 5, 10. Now, in the present class, which tests are there?
Sir, in class 6, they are going to study the divisibility test for 3, 9 and 4.
Sir, what previous knowledge is required for this?
For this, they should clearly understand what is the difference between number and digit.
Please tell us the difference between them, sir.
Exactly. Now, you can see the slide. There is a number 307, which is formed by using the digits 3, 0 and 7. In general, any number is formed using one or the more digits from 0 to 9.
Okay. Now, as they know about the difference between number and digits, tell us about a divisibility test.
Well, sir, I want you to have a close attention on the 4 numbers that are shown on the slides. Just by looking at these numbers, can you tell that is there any common property they follow?
Exactly, yes. These numbers are nothing but the same numbers in the table 3.
Exactly, sir. This 15, 27, 21 and 30 are the numbers from the table of 3. Now, we will see one more property of the same numbers. Let's go to the next slide. Now, I am going to add the digits of these numbers.
One can easily notice that these sums of the digits, that is 6, 3, 9, 3, are also divisible by 3.
That is very good observation, sir. Now, tell me that if sum of the digits is divisible by 3, can you tell me a number whose sum of the digit is divisible by 3?
Take an example, 57. In 57, the sum of digit 5 and 7 is 12. And 12 is divisible by 3.
Okay. Now we will see that whether this 57 is divisible by 3 or not. For that, we need to take the long division. If I divide this 57 by 3, what I am going to get is quotient as 19, but the remainder as 0. So 57 is definitely divisible by 3.
Okay.
Now I am going to give you a number. Okay, can you tell whether this number is divisible by 3 or not?
Of course. You tell me a number and I will tell if the number is divisible by 3 or not.
Now take for example 67.
For that I shall add the digits in the number 67, that are 6 and 7. The sum of the digits is 13 and 13 is not divisible by 3. So the number 67 is not divisible by 3.
Very good, sir. This 67 is not divisible by 3, but we can have a complete long division method to see the same thing. If I divide 67 by 3, the quotient will be 22 and the remainder is 1, which is not 0. Then definitely I can say that this 67 is not divisible by 3.
In short, if the sum of the digits in a number is divisible by 3, the number itself is divisible by 3.
Yes, sir. In similar way, the test of divisibility of 9 works. Let us see how. Now I am going to give you 4 numbers. Now can you see that these 4 numbers are nothing but the same numbers in the table of 9. And in the same way, if I add the 2 digits from this number, let's see what are we going to get. Now take for example number 54. If I add the digits 5 and 4, we are getting 9.
That's fantastic. Now take the number 783. The sum of its digit is 7 plus 8 plus 3, that is 18. And 18 is divisible by 9. So 783 is divisible by 9 too.
Let's see it for completely, that if I divide 783 by 9, what we are going to get. Here by using long division we have done this. We are getting the quotient as 87 and remainder as 0. And it is clearly seen that 783 is divisible by 9. Whereas let me take one more number, that is 843, in which the digits are added up to 8 plus 4 plus 3 is giving us 15. Now 15 is not divisible by 9. So you can have a look at the long division also, that in 843 if I divide it by 9, I am going to get the quotient as 93, but the remainder here is 6, which is not 0. So I can clearly say that 843 is not divisible by 9.
In short, if the sum of the digits in a number is divisible by 9, then the number is divisible by 9.
Now we will move on to the next test. Here are few numbers: 536, 308, 716, 924, 620 and 132. What common properties do you think they follow?
I think all of these are even numbers, as the last digit is even.
Yes, the last digit is even, so the numbers are divisible by 2. But now have a close look at the last 2 digits. And now can you tell me what common thing you can find in them?
Sir, 16, 24, 20, 32, 8, 36, the numbers are from the table of 4.
Very good, sir. So let's check completely whether the number 536 is also divisible by 4 or not. If I long divide this 536 by 4, what we are getting is the quotient as 134 and remainder is 0. That means 536 is also divisible by 4.
Exactly. How nice. This test is easy as well. All we need to check if the last 2 digits are divisible by 4 or not. But what about checking if 345 is divisible by 4 or not?
Okay. In case of 345, you can clearly see that the last two digits are 45 and 45 is not divisible by 4. And if we long divide the 345 by 4, what we are going to get is quotient as 86, but the remainder here is 1, which is not 0, and which clearly tells us that this 345 is not divisible by 4.
Okay. In short, if the number formed by last two digit is divisible by 4, then that number is also divisible by 4. Thank you. Hello everyone. In this session, we are going to discuss the unit equation. Sir, what previous knowledge a student should have to understand this unit?
To understand this unit, they should have a knowledge of a comparison, that is less than, greater than or equal to.
Sir, what is an equation?
Sir, to understand what an equation is like, we shall see the example of seesaw. While playing the seesaw, the heavy person moves the seesaw downward. At the same time, the person on the other side goes upward. The balanced position of seesaw is like an equation.
Sir, even the weighing scale in the textbook is showing the balanced equation or position we can say, which will help us to understand the equality.
Yes, in another example, we can see that there is an expression on the left side, that is 5 into 4, which is giving us the number 20. Now, there is one more expression on the right hand side, that is 24 minus 4, which is giving us 20. Now, you can see that as both the expression on left and right hand side are giving us the number as 20, we can say that there is an equality and these two expressions are equal.
Sir, we can even write equal to sign between these two expressions.
Yes, sir. Now, in the next example, we can see that there is an expression of 10 into 2 on the left hand side, which is giving us the answer as 20, but on the right hand side, there is an expression 25 minus 7, which is giving us the answer as 18. Now, you can see that the numbers 20 and 18, they are not equal. So, we can say that whenever there is an imbalance, it shows inequality.
Then I guess, sir, we cannot use the same equal to sign as we have used in the previous expression.
Yes, in fact, when the expressions are unequal, we can show the inequality by using not equal to sign, which is already shown in the slide at the top.
Sir, now show us an example where equality is used.
Alright, sir. Now consider the next example. Here, in this example, the distance between the home and school is given as 250 meters and the distance between shop and school is given as 155 meters. Now, we are supposed to find what is the distance between home and shop.
And how to find it, sir?
Here, the distance between home and shop is not known to us. So, we can replace this question mark over here by a letter. Any letter you can use from the alphabets. Now, here we will